The universe as we know it is unraveling, and the James Webb Space Telescope is at the heart of this cosmic upheaval, revealing sights so strange, so baffling, that they're forcing us to rethink everything we thought we understood about reality itself. A Nobel Prize-winning mind has issued a staggering warning. What we're seeing through this telescope suggests we're living in a universe far different from the one we imagined, a place where the rules of physics, time, and space might be mere shadows of a grander, more mysterious truth. Picture this: a telescope so powerful it peers back nearly to the dawn of time, capturing light that's been traveling for over 13 billion years, showing us galaxies, stars, and cosmic phenomena that defy every model we've built. These discoveries aren't just tweaking our theories, they're shattering them, hinting at possibilities so wild they sound like science fiction. Parallel universes, cosmic cycles, and ancient relics from realities that existed long before ours. Buckle up, because today we're diving deep into the most shocking findings from this telescope, exploring what they mean for humanity and why they're leaving astronomers speechless, emotional, and awestruck at the vastness of it all. Imagine staring into the night sky, knowing the faint glimmers you see might not just be stars, but echoes from a universe that died eons ago. This telescope, humanity's most advanced eye into the cosmos, has spotted something extraordinary. Galaxies so massive, so fully formed, that they shouldn't exist according to everything we know. These aren't your average star clusters. They're behemoths, rivaling our own Milky Way in size, yet they were already thriving just 500 million years after the Big Bang. To put that in perspective, that's like finding a fully grown adult in a cosmic cradle when the universe was barely an infant. Our models scream that this is impossible. There simply wasn't enough time or matter in the early universe for such giants to form. Yet there they are, glowing defiantly in the telescope's lens, mocking our understanding of how galaxies are born. Astronomers have dubbed these anomalies universe breakers, and the name fits perfectly. These structures are tearing apart the foundations of cosmology, forcing scientists to question whether the Big Bang was really the starting line we've always assumed. But it's not just the size of these galaxies that's causing jaws to drop. Their very existence challenges the timeline of the universe's evolution. According to the standard story, the cosmos began with a fiery explosion 13.8 billion years ago, expanding rapidly in a period called inflation, then slowly coalescing into stars and galaxies over hundreds of millions of years. But these universe breakers are flipping that narrative upside down. They're too big, too bright, too complex for their age. One galaxy, spotted near the constellation of the Big Dipper, is pumping out stars at a rate that defies logic, its light screaming across the cosmos with an intensity that shouldn't have been possible so early on. Scientists are scrambling to explain it. Could there have been more matter in the early universe than we thought? Did gravity work differently back then? Or, and this is where things get truly mind-bending, could these galaxies be remnants of something older, something that predates the Big Bang itself? This brings us to a radical idea, one championed by a brilliant Nobel laureate who dares to suggest that the universe isn't a one-and-done story, but part of an eternal cycle of birth, death, and rebirth. Picture the cosmos as a phoenix, endlessly burning out and rising anew from its ashes. This theory, known as conformal cyclic cosmology, proposes that what we call the Big Bang wasn't the beginning, but a bounce, a transition from an older universe that expanded, cooled, and faded until it collapsed into a state so smooth and timeless that it sparked a new cosmos. The evidence? It's hiding in plain sight, etched into the cosmic microwave background, that faint glow of radiation left over from the universe's earliest days. Researchers have spotted strange patterns there, circular hotspots, glowing brighter than they should, scattered across the sky like cosmic fingerprints. These anomalies, dubbed Hawking points, could be the ghosts of supermassive black holes from a previous universe, their energy carried forward into ours as a whisper of what came before. Let's pause to let that sink in. The idea that the universe we live in might be just one chapter in an infinite saga is nothing short of breathtaking. It's emotional too, because it forces us to confront our place in something far grander than we ever imagined. Every star, every galaxy, every particle of dust floating in the void could be a relic of a reality that existed before time as we know it. And this telescope is giving us the first real clues to prove it. Those circular patterns in the cosmic microwave background aren't just random noise. They're precise, measurable, and eerily consistent with what this cyclic model predicts. Each spot is roughly the size of the full moon, glowing with a subtle intensity that stands out against the universe's ancient afterglow. Skeptics argue they could be statistical flukes, but the data keeps piling up, and the patterns keep appearing in observations from multiple satellites. If these are indeed the echoes of a prior cosmos, we're staring at evidence that rewrites the story of everything. Now let's zoom in on another bombshell from the telescope's findings: the mystery of cosmic expansion. For decades, scientists have measured how fast the universe is stretching using a number called the Hubble constant. On paper, our theories predict it should be about 67 kilometers per second per megaparsec, a tidy figure based on the physics of the early universe. But when we measure it in the real world, using exploding stars, pulsating giants, and gravitational lenses, the number jumps to 73 kilometers per second per megaparsec. This mismatch, known as the Hubble tension, has been a thorn in cosmology's side for years, but the telescope's razor-sharp observations have only deepened the crisis. Its data confirms the higher number, suggesting something fundamental is wrong with our models. Could it be that dark energy, the mysterious force driving the universe's acceleration, isn't constant but changes over time? Or is something even stranger at play? Here's where the telescope's discoveries take a turn into the realm of the cosmic wild. Some scientists are proposing a jaw-dropping explanation. Our universe might be colliding with others. Yes, you heard that right. Our cosmos could be bumping into parallel universes, merging and stretching in ways that mess with our measurements. Imagine the early universe, still hot and chaotic, not expanding in isolation, but interacting with other cosmic domains in a vast multiverse. These collisions could have warped the fabric of space-time, speeding up expansion in ways we never accounted for. Mathematical models exploring this idea are starting to show startling results. When you factor in these cosmic interactions, the expansion rate aligns much closer to what we observe. It's as if the universe is whispering that it's not alone, that it's part of a larger, interconnected tapestry we're only beginning to glimpse. This multiverse idea isn't just a sci-fi fantasy, it's gaining traction because it explains so much of what the telescope is seeing. Those massive early galaxies, the strange expansion rates, the mysterious patterns in the cosmic background, They all start to make sense if our universe is just one bubble in a frothy sea of realities. And the emotional weight of this hits hard. If true, it means we're not just specks in a single universe, but part of an infinite network of existences, each with its own stars, galaxies, and perhaps even life. The telescope is showing us that the cosmos is wilder, weirder, and more interconnected than we ever dared to dream. And it's humbling to realize how little we truly know. Let's shift gears to another mind-blowing discovery: the era of reionization, when the universe went from a dark, foggy place to a starlit wonderland. Picture the early cosmos, just a few 100 million years after the Big Bang, shrouded in a thick haze of neutral hydrogen gas that blocked all light. Then, the first stars ignited, their fierce radiation burning away the fog, ionizing the gas and creating bubbles of clear space where light could shine through. Scientists thought this process, called reionization, took hundreds of millions of years, starting around 300 million years after the Big Bang. But the telescope has thrown a cosmic curveball. It found a galaxy glowing fiercely just 330 million years after the Big Bang, blasting out ultraviolet light so intense it carved a bubble of ionized gas 650,000 light-years wide. This shouldn't have happened so fast. The light from this galaxy, carrying the unmistakable signature of Lyman alpha radiation, pierced through a universe that was supposed to be opaque. It's as if the cosmos flipped on its lights far earlier than we thought possible. This discovery is more than just a timeline adjustment. It's a full-on assault on our understanding of how the universe lit up. The lead researcher, stunned by the findings, admitted that this galaxy's light shouldn't have escaped the dense hydrogen fog at such an early stage. Yet there it is, shining like a beacon from a time when the universe was barely a toddler. The data suggests either reionization happened much faster than we thought, or it started earlier, maybe even driven by smaller, less massive galaxies we've overlooked. Or in a twist that ties back to the cyclic universe idea, could these early galaxies be powered by remnants of a previous cosmos, their energy somehow lingering to spark this rapid transformation? The telescope's images are forcing us to rethink the very mechanics of how the universe became transparent, and it's an emotional gut punch to realize how much we've underestimated the cosmos's complexity. But the surprises don't end there. The telescope has also spotted galaxies that are churning out stars at an astonishing rate, far beyond what our models predict. These stellar factories are pumping out new suns so quickly that they're rewriting the rules of galaxy formation. Some researchers speculate that these galaxies might be fueled by exotic objects, like primordial black holes or even dark matter clumps, that amplify their star-forming power. Others wonder if these galaxies are somehow tapping into energy from a prior universe. Their rapid growth a clue to a cosmic handoff we're only beginning to understand. The emotional weight of these findings is overwhelming. Each new image from the telescope is a reminder that the universe is a living, breathing puzzle, constantly challenging our arrogance and inviting us to dream bigger. Let's dive deeper into the cyclic universe idea, because it's one of the most electrifying concepts to emerge from these discoveries. The Nobel laureate behind this theory argues that the universe doesn't have a single beginning or end, but exists in an eternal loop. When one universe expands to its limit, all matter decays into pure energy, light without mass. In this strange, timeless state, the universe becomes smooth and featureless, setting the stage for a new Big Bang. But here's the kicker. This isn't just a wild guess. The telescope's data, combined with earlier observations of the cosmic microwave background, is providing tantalizing hints that this might be true. Those Hawking points, those glowing disks in the sky, could be the scars of ancient black holes from a universe long gone. Each one is a testament to a reality that lived, died, and passed its energy forward to us. It's a profoundly moving thought. The light we see today might be a love letter from a cosmos that no longer exists. Skeptics, of course, are quick to push back. Some argue that these patterns could be random fluctuations, not cosmic relics. Others say the math behind the cyclic model is too speculative, lacking the hard evidence needed to overturn the Big Bang paradigm. But the telescope's findings are making it harder to dismiss these ideas outright. Every new galaxy, every unexpected anomaly adds weight to the possibility that our universe is part of something far larger. And the emotional resonance of this can't be overstated. It's not just about science, it's about our place in an infinite story, one where every ending is a new beginning, and every discovery brings us closer to understanding our cosmic roots. Now let's talk about the telescope itself, because it's the hero of this story. Launched into the void with mirrors the size of a tennis court, this marvel of engineering is capturing light from the universe's earliest moments with unprecedented clarity. Its infrared eyes can see through cosmic dust, revealing hidden galaxies and stars that no other telescope could detect. Each image it sends back is a time machine, showing us the universe as it was billions of years ago, when the first stars were born and the cosmos was still finding its shape. But it's not just the beauty of these images that's captivating, it's the questions they raise. Why are these galaxies so big? Why is the universe expanding faster than it should? And what are those strange patterns in the cosmic background? The telescope isn't just showing us the universe, it's showing us how much we don't know. And that's both humbling and exhilarating. The emotional impact of these discoveries hits on multiple levels. For scientists, it's a mix of frustration and excitement. Decades of theories are being tested, and some are crumbling under the weight of new evidence. For the rest of us, it's a reminder of how small we are in the grand scheme, yet how powerful our curiosity can be. The telescope is a testament to human ingenuity, a machine built by dreamers who dared to look beyond the horizon. And what it's showing us is a universe that's alive, dynamic, and full of surprises. It's a story of creation, destruction, and rebirth, played out on a stage so vast it dwarfs our imagination. Every new finding is a call to wonder, to question, and to feel the awe of being part of something so much bigger than ourselves. Let's circle back to those universe breakers, because they're the spark that's igniting this cosmic revolution. These galaxies, glowing in the telescope's gaze, are forcing us to rethink the very building blocks of the cosmos. One theory suggests they could be powered by dark matter, that invisible substance that makes up a quarter of the universe's mass. Perhaps dark matter clumped together in ways we didn't expect, acting as a cosmic scaffold that let these galaxies grow faster than our models allow. Another possibility is that the early universe was denser than we thought, packed with enough raw material to birth these giants in record time. But the most tantalizing idea is that these galaxies aren't entirely ours, that they're relics from a previous universe, carried forward through the Big Bounce and seeded into our cosmos like cosmic heirlooms. This idea ties back to the cyclic model in a way that's almost poetic. If the universe is indeed eternal, cycling through phases of expansion and collapse, then these massive galaxies could be the last survivors of an earlier era. Their size and complexity a testament to a cosmos that lived before ours. The telescope's ability to see them is like finding an ancient artifact in your backyard. Proof that history is deeper and richer than you ever imagined. And the emotional weight of this discovery is profound. It's not just about stars and galaxies, it's about the story of existence itself. A tale that stretches back beyond the Big Bang and forward into an infinity we can barely comprehend. But the telescope's revelations don't stop at galaxies. It's also shedding light on the mysterious forces shaping the universe's fate. Dark energy, that enigmatic force driving the cosmos apart, is coming under new scrutiny. The telescope's precise measurements of distant supernovae and galaxy clusters are hinting that dark energy might not be a constant force, but something that evolves over time. If true, this could explain why the universe's expansion is speeding up in ways our models can't predict. It's a chilling thought. The force that's tearing the cosmos apart might be dynamic, unpredictable, and tied to processes we don't yet understand. Could it be linked to those cosmic collisions with other universes? Or is it a remnant of energy from a prior cosmos, lingering like a ghost in the machinery of our reality? The telescope's discoveries are also forcing us to confront the limits of our technology and our minds. Each new image is a humbling reminder that the universe doesn't care about our textbooks or our assumptions. It's a wild, untamed place, full of secrets waiting to be uncovered. And yet, there's hope in this uncertainty. Every anomaly, every universe breaker, every strange pattern in the sky is an invitation to push further, to ask bigger questions, and to dream of answers that might redefine reality itself. The telescope is our guide, our beacon in the cosmic dark, and its findings are a rallying cry for anyone who's ever looked at the stars and wondered what lies beyond. As we wrap up this journey, let's reflect on what these discoveries mean for us as a species. The telescope is showing us a universe that's stranger, more complex, and more beautiful than we ever imagined. It's a place where galaxies defy time, where the cosmos might be part of an infinite cycle, and where our reality could be just one thread in a multiverse tapestry. These ideas are more than just science. They're a call to embrace the unknown, to feel the weight of our smallness and the power of our curiosity. The universe is speaking to us through this telescope, and its message is clear. There's so much more to discover, so much more to understand, and so much more to feel. So let's keep looking, keep questioning, and keep marveling at the cosmic wonders that await us.